Hi and welcome to today's maths class. Today we are having a very interesting problem here. If one root is square of the other root of the equation x square plus px plus q is equals to 0, then the relation between p and q, and here four options are given. One is p cube minus q into 3p minus 1 plus q square is equals to 0, and the second one is p cube minus q into 3p plus 1 plus q square is equals to 0. And in case of 3 and 4, the signs are changed. Here these are minus, and here this has been changed to plus. So out of these four relationships, which one correct relationship between p and q we have to find out. What is given in our question? The condition is one root is square of the other root of the equation. So let us consider that the two roots of the given equation are alpha and alpha square. One is square of the other root. So we can consider alpha and alpha square. By the property of the quadratic equation, we can say that alpha plus alpha square is equals to minus p, and alpha into alpha square is equals to q. We'll explain how this we have derived. If there is a quadratic equation ax square plus bx plus c is equals to 0, and the two roots of this equation are m and n, then there is a property of the quadratic equation that m plus n is equals to minus b a, and mn is equals to c by a. So this property we are applying in this case. Here our equation is x square plus px plus q is equals to 0. So if the two roots we have considered alpha and alpha square, then we can write that alpha plus alpha square is equals to minus p. Actually, what is p? This is the coefficient of x in this equation. The coefficient of x square is 1, so it is minus p by 1, that is equals to minus p, and the product of these two roots is equals to q by 1. Actually, q is the constant term in this equation and x square's coefficient is 1, so it will be q by 1, that is equal to q. So from these two relationships, now what we can do, from this alpha plus alpha square is equals to minus p, we can write that alpha common taken, and inside it will be alpha plus 1, that will be equals to minus p, and if we cube both the sides of the equations, then it will become alpha cube, and it will become alpha plus 1 cube is equals to minus p cube by cubing both the sides of the equation. Now alpha cube will be outside, and inside a plus b whole cube formula we can consider to break this. So this will be alpha cube plus 1 cube plus 3 alpha within bracket alpha plus 1, that will be equal to minus p cube. Now we have alpha into alpha square, which is alpha cube, that is equals to q. So alpha cube we will replace with q. Inside also this alpha cube will be q, plus this will be 1 and plus 3 alpha into alpha plus 1, that is equals to minus p. So this will be minus p. Bracket will be closed, and on the right hand side this will be minus p cube. Now we can break this equation. Q into q square plus q minus 3pq, and we will take this minus pq to the left hand side of the equation. Now we can write that pq will do is p cube will be as it is, and we will take q common, and inside it will be 3p minus 1 plus q square is equals to 0. So from the four options given in our question, our answer matches with the first option, which is p cube minus q into 3p minus 1 plus q square is equals to 0. So this is the correct option.